All right, so we're talking about sectors here, so I kind of wanted to show you. If you are on level, we will give you the sector formulas, but if you are not on level, if you're in K level, you are going to have to derive these, okay? So I'm just drew a picture of a sector. Parts are parts. The angle here is called the central angle, and that is theta. The radius is, of course, the radius of your sector, and S is the arc length, okay? So let's do radians first. So arc length, remember, is like a portion of circumference. If it was all the way around the whole circle, we would just say it's circumference. But it's just a little portion of circumference. If you're in radians, you would say that the arc length is equal to theta over 2 pi, whatever theta is divided by 2 pi, times the formula for circumference, which is 2 pi r. It's kind of like over 1. But what happens is the 2 pi's cancel, so S is just equal to theta times r. Or I could say S is equal to theta, the central angle, times r, the radius. So in radians, that works out really nicely. Area is going to be theta over 2 pi, and the formula for the area of a circle is pi r squared. Okay, so that's like over 1. So what happens is the pi's cancel, and so what we get is area is equal to theta r squared divided by 2. So there's the formula for area in radians. The reason I know it's radians is because I'm going theta over 2 pi, and 2 pi is radians. When I figure out degrees now, I'm going to use over 360. So arc length will be theta over 360 times the formula for circumference, which is 2 pi r. Okay, I'll call it over 1. So what happens, the only thing that cancels out is 2 and 360 reduce. This becomes 180. So we could say that arc length is equal to theta times pi times r divided by 180. So that's your formula for arc length if they give you the angle in degrees. And then for area, it would be equal to theta over 360 times pi r squared. And I guess the easy thing about this is that nothing cancels. There's nothing in common we could cancel. So area is just theta pi r squared divided by 360 degrees. So those are our formulas, okay? I do not, quite frankly, memorize them. I just derive them. It takes like a second to derive them. And I'll just give you this little word that these were a part of tax testing. I was just looking at an old tax test, and knowing sector formulas, they kind of just thought you should know them because of your knowledge of geometry. All right, so let's go ahead and consider our problems here. They tell me that the radius is 1/4 feet, 1/4 of a foot, anyway, and S is equal to 6 feet, and they asked me to find theta. All right, find theta. Well, do I have a formula that has S and R and theta in it? Yeah, we just found one. And so they asked me to find theta, so I think I'll use this formula up here because it's the easiest one. They didn't really tell me to do it in degrees or radians, but I think I'll use the easy formula that says, I think I'll change the pen color here. Mix it up a little. So it says S is equal to theta times R. So I know S is 6, and I don't know theta, but I know R is 1/4. So when you multiply these together, you just get 6 is equal to theta over 4. So if I was trying to solve for theta, I guess I would just multiply both sides by 4. I'll continue this right here. So 4 times 6, 24. And here the 4's cancel, so that's theta. Now, it just says theta is 24. Is it going to be degrees or radians? Well, I use the radian formula, so it's going to be radians. So I could say theta is equal to 24 radians, because I use the radians formula. If I had used the degree formula, would my answer come out in degrees? Yes, but I chose the easier one, so that's how I got that. All right, let's look at this next problem here. So it looks like they asked me to find S, and the angle is in radians, so I will use that formula, S is equal to theta times R. I wrote it down right there. It's kind of up farther, but can't see it now. So S is equal to theta, which is pi over 6, times R, which is 3. And so we could even call it like 3 over 1 if we wanted. And so S is equal to 3 pi over 6. And 3/6, of course, is just 1/2. So S is going to be equal to pi over 2. Make sure you can see that. You can't see it that well. Let's scoot it up. And that would be our answer for that problem.